Hello everyone, I wanted to give a brief overview of the work that I did for 4.7.2.1 project Tic-Tac-Toe in the entry-level Python programming course offered on Python Institute. So I'm assuming that you've already read over the assignment and all of the restrictions and requirements that it puts in place. So the first thing we should do when trying to kind of program anything is take a look at what have a roadmap in mind of what we want to do. So the first thing we're kind of told to do in the assignment is to set up the board. And we're told that the board needs to consist of 3 elements, where each element is another 3-element list. So our 0th element contains elements 1, 2, and 3. Our first element contains elements 4, 5, and 6, and then our second element is again a 3-element list with elements 7, 8, and 9. So that's pretty easy to do, set up the board. Now we need a way to display the board. And so this is accomplished through a little bit of trial and error. Uh-oh. Didn't mean to do that. And so what you can do when you're working on your display board function is to just kind of copy paste the way these pluses and minuses are spaced and paste those into the print function as strings. And then make sure that when you are setting up your print function within the display board function, that you're actually referring back to the elements of the board. So board 00, board 01. That way, when you go to use the display board function, it will automatically update to an X or a 0 if one is placed in that spot. So here's how you would set up your function. So then in step 3, we need to use this make list of free fields function, which is going to give us what spots are free and what ones already have an X or a 0 in them. So when I set this up, I kind of list some variables right here. And this first one is there just because the assignment tells us that spot 5 is always going to be an X. That's the computer's opening move. So that is board 1, 1 is where we're placing that X. So hopefully you're okay with that, because that is row 1, element 1. Now the free spots and the free fields, I know that I'm going to need lists for those, and to just kind of have something in place, I just use this default kind of hyphen here so that a list at least exists, and then I'll take care of populating the lists with what I want inside the make list of free fields function. So I use the keyword global because I don't want to make a new variable inside this function. I want it to refer back to these ones. So that's why I have global and then the word board, free spots, and free fields. So the first part of this function is I want to be sure that I'm starting with a clean slate. So I use free underscore spots dot clear to empty my list, and same thing with free fields. Now in our assignment, we're told that this make list of free fields function is going to be a list of tuples, while each tuple is a pair of row and column numbers. So I went ahead and did that because they gave me that information. So I'm just going to iterate for I in range 0 to 3, for j in range 0 to 3, and what I told this function to do is check all the board spots and determine whether or not they're an integer. So if they are an integer, then we want to append tuple ij to our list of free fields. So for example, if board 00 is an integer, then we would add the tuple 00 to our free fields list. It's pretty simple why we would check for it being an integer or not, because if it is not an integer, that implies that we have already placed an X or an O in that spot. However, practically speaking, I think that this is conceptually a little difficult to think about, So I like to also have this free spots variable that then looks at our list of tuples and converts them back to the numbers as we think of them on the board. So I have this board number variable, and we're going to iterate for I in range length of free fields, and it's going to take the ith element, or if we're putting it in simple terms, the ith element in our first tuple times it by 3. So let's just, as an example, say we plug 0 into this, because if board spot 0, 0 is free, then free fields 0, 0, well, that's referring to the first element of the first tuple, which would just be element 0. And so 0 times 3 is 0, so this cancels out. And then we've got free fields 0, 1. So again, that's going to be free fields 0, 1 is going to be 0 plus 1. So then this function correctly will translate tuple 0, 0 into number 1. And then, as another example, it'll translate tuple 0, 1 into number 2. Because if you look at free fields of 0, 0, 0 times 3, so if we're hypothetically, if we're considering plugging in tuple 0, 1 into this, well, the function would take free field 0, 0, which is going to be 1, or no, sorry, it'd be 0 times 3, and then plus free fields of 0, 1. Well, 0, 1 is also going to come back. It'll be a 1, and then when we add a plus 1, that gives us 2. So then we correctly convert tuple 0, 1 to 2. So this might be something you need to work out yourself, but just a little pointer. Of course, convince yourself that this is true, but note that this is not referring to what's in the elements in your board list. This is referring to the tuples in the free fields list. And then once it correctly converts that tuple back into a number on the board, we add that to our free spots list using the append method here. So this function, again, convince yourself that this is true. This will probably take some time for you to think through, especially if it's your first time working on something like this. But this function is correctly tracking what spots on the board are available for play. So then the next thing we need to do is we need to look at whether or not there is a victory. And what scenarios do we have for winning tic-tac-toe? Well, if all the characters are the same across the top row, so if these are all O's or all X's, that would be a victory. So to translate that to Python, if board 0, 0, board 0, 1, and board 0, 2 are all the same, which is what we say here, then that's a victory. So we would want to display the board, and we would want to print whatever that object is in there, whether it's a 0, or sorry, whether it's an O or an X, and then we would want to print wins. So the game is going to return X wins or O wins. Now, this part here, this input, what I found is when I ran and executed this program, once a victory occurred, it would then close out, and then it's kind of frustrating because you can't see the final output of your code. So by using this prompt, it's going to cause the program to stay open until you press enter, and then it'll exit the game. So in our victory for function, we also have all the other ways you can win. So you can have X's or O's across the first row or the second row, or you could have them going down the 0 column, the first column, or the second column. And then lastly, you have to keep in mind that you could have diagonals as well, which is what these two cases account for. The other scenario for the victory function is there could be a tie. So the quickest way I found to define whether or not there's a tie is to look at the length of free spots available. And if it's 0, meaning we've placed an X or an O in every spot, and none of these other scenarios have been satisfied, then it must be a tie. Okay, so then the next thing we need to do is we've set up our board, so we have we defined these numbers and these spots. We have a way to display the board. We have a way to track free spots in the board. We have a way to determine when a victory has occurred, but now we need the computer to actually play a move. Sorry, I put an X there. So we work on the draw move function to try to get our computer to take its own turn, and we don't want the computer to pick a spot that's already in play and ride over it or anything like that. So in our draw move function, you'll remember I have this computer move variable from earlier up here that was just kind of set as some default value. Now we're actually going to change that. So, and again, no parameters here. I didn't need them. So we're going to import the random module, which you'll learn more about in the second Python course if you go onto that. And then I'm going to write over that computer move variable by using the random module and utilizing the choice function within the random module. That's what this is denoting, random.choice. It's formatted module.function. And so we're picking a random choice from our free spots because we're told in the assignment that we don't need to worry about the game knowing AI or any kind of advanced techniques. We're just having it draw a random integer number. But we don't want it to just pick any random integer number 1 through 9 because it could pick a spot that's already been taken. So it seemed more intuitive to me to have it make its random choice from the list of free spots available. And I mean, it's probably the shortest function on here. Okay, so we now have a way for the computer to play its move. So we're ready to actually kind of go through the steps of the game, and I just lumped all the rest of the code into the enter move function. So while victory 4 is false, while that's returning a false value, I'm using this to create a loop because I need, when I execute this code, I need to go through a series of steps over and over until someone wins or there's a tie. And then Python likes us to use the try and except method to handle any exceptions. So we're going to try, and what we're trying is we first run the make list of free fields function because we want to check what the free spots available are and make sure all that gets updated. Then we want to display the board, which will automatically have an X on spot 5. And then our player move is we're going to prompt the user to pick a spot where they want to play at. Now, we need to be kind of keeping in mind that people might put in unintended inputs. So I set up this other while loop that basically says if someone picks, if their input, their player move, is not in the list of free spots, then they need to be told that's not a valid spot and try again. And so they'll get that message over and over and over until they finally enter something that's in the free spots list we made earlier. So once they've picked something in free spots, we then need to update the board. So if the player move is equal to 1, then we want board 0, 0 to be O. So we're changing this list up here. And we would change this value to an O because the player gets O's, the computer gets X's. Another example is like if the player move is 6, so if the user just types in a 6, then we need to update board 1, 2 to be an O. Now, the next logical step is for the computer to take a turn. But before we do that, we need to check to make sure a victory hasn't occurred. So I threw in this other if function if victory4 is true, then we need to execute the victory4 function. So in other words, if we look at what these are, if victory4 returns true, then we need to go ahead and go through these set of instructions. But if the victory4 resolves to false, which it always will after the first player move, then we want to proceed on with the game. So we would display the board again, showing the updated board with the player's move, and then we want to re-update our list of free fields. Once we've updated the list of free fields again, we're ready to execute the draw move function, and then based on whatever the computer randomly draws, we'll place an X there. And so since a turn occurred, we need to once again update the list. We need to update the list of free fields. So from there, we're kind of done. So we just click, we put this continue in here. And because we're in the while loop until the victory4 returns true, it's going to go back up here and iterate through all this again. And then I'm not sure that this is totally bug-free, so I just put in my else block, I don't know what happened, check enter move function in case I come across something, but I haven't lately. And then in the except column, that's just if something else crazy gets put in there, it's prompting the user to try again. So, and then lastly, we have where we're invoking the enter move function to begin the game. So I'm going to close this out and we'll run through a demo real quick so that you can see that it works. So I'll play 9, put a 2 in. I'll try 3. And looks like this computer's going to win unless I do, well actually I could win either way, 1 and 6, right? So 1, and I won. So now it says press enter to exit the game, so this screen won't close out until I press enter. So I'll do that, and then it closes. So I hope you found this tutorial helpful. Of course, you may need to pause the video, throw out my code to see what I did, but I just wanted to post this real quick to try and help out and share with other people what I did, because while I was working on this, I actually got on YouTube and hadn't found any solution like this shared anywhere, so I thought it'd be worth putting up. So thank you for your time, and I appreciate you checking out the video.